Thank you to everyone for joining us today for the first webinar in our collective series entitled Operational Data to Actionable Intelligence. My name is Scott Drapp, Sales Director here at Quartic, and I'll be hosting today's webinar. I'm joined by Rajiv Anand, our CEO and founder, as well as Vinod Rodriguez, our Vice President of Customer Success. Before we get started, I just wanted to highlight the specific focus of today, and that is giving you a comprehensive overview, predominantly via a demo, of the complete solution offering of Quartic. And that consists of Q Data, Q Intelligence, and Q Applications. We will share everything from data collection with context, streaming analytics and machine learning, as well as sample AI applications within our robust application portfolio with artificial intelligence. Please note that each subsequent webinar will dig deeper into each component of the platform and the various applications for the underlying industries that they serve. We'll wrap things up with a question and answer session, so feel free to post any questions during the webinar in the chat, or you can post them in the chat at the closing during the Q&A session. With that being said, I'll hand it over to Rajiv to kick us off.
Thank you, Scott. Sorry about that. So welcome to this webinar. If I could ask a question why you're attending this webinar, I know everyone can't answer, especially if that question was posed to end users in the audience. The answers are likely that you're trying to make sense of what you really need for the future manufacturing platform. What type of analytics you need, self-service analytics, what machine learning, what AI. And many of you might be doing some form of analytics. Typically, these are offline analytics for root cause analysis, or you might have specific multivariate type of solutions that you're using. But most importantly, many of you are waiting to see what the system or platform for the future will look like. And we actually get that discussion with some customers where they would say, we want to see how things evolve and what this platform looks like. So some of you might be dealing with status quo or what I call stopgap solutions, but waiting for them for too long is just not affordable from a business point of view. So as you're in that situation, you're likely in one of these three situations or one of these three categories. So the first one is what could be categorized as noise. And that's from legacy software system vendors, not OT systems, but data historians, SCADA systems, what have you. And the other is from cloud hyperscalers. So yes, it is true that building a final solution requires a lot of components, managed services, but getting those managed services and building and maintaining a platform is not sustainable, not for manufacturing. The cloud provider should really be used for infrastructure as a service, hopefully without getting into a cloud lock that you don't want. And when it comes to legacy vendors, no, simply putting a legacy historian or SCADA system in a virtual machine in the cloud doesn't make it digital. Your company has probably invested in data scientists, that's another likelihood, who are not being very productive because the right features, data, and problem definition isn't available. In the meantime, your OT and manufacturing analytics teams are trying to solve problems with a plethora of analytics tools. Like I said, typically offline, self-service, but you cannot operationalize any of those analytics. Which means some small problems are being solved, but the business, the management, the enterprise were expecting something transformational, something sustainable that makes an actual impact on the business, which isn't happening. So before we go into what a platform should look like and why you need a platform, why are we doing all this? What is it that we need to focus on? What is it that we're solving for? To me, it is building a new generation of industrial applications. You should be able to focus on building those applications that deliver results. The rest is detail, and that detail should be covered by a system or a platform, or more precisely, a platform as a service. And that's what we're going to discuss today in this webinar, and then, as Scott said, go into details in the next series of seminars. So what is it that we're building, and what is it that we're solving for? The answer to that question is a manufacturing operations platform or an Industry 4.0 platform. And what are the main characteristics of that platform, or what does that platform mean, or what does Industry 4.0 mean? It's essentially, we have systems of control, we have systems of record. It is about building a system of intelligence, or if you want to use the process control systems analogy, you could call it an intelligence control system, eventually leading us to have autonomous control. But along the way, we have to do this journey of operationalized analytics. So what should this system do? What does this system of intelligence mean? It essentially is to allow you to analyze and, yes, also control a wider context and time horizon of the entire manufacturing enterprise. I refer to this IIRA framework, which some of you might be familiar with. If you're not, I would highly recommend to look into it. It brings together what is it that we're trying to do. We're essentially doing a zoomed out view of our entire manufacturing enterprise by analyzing a zoomed out view, a bigger picture, a wider horizon over a wider time frame. And so what should it allow you to do? It should allow you to see and control that zoomed out view. And what does that mean? That means multiple types of data in a meaningful context. And secondly, a continuous analytics that takes those data streams and gives you the output of that analysis. So it is about operationalizing those analytics. Yes, you might have to perform self-service analytics, root cause analytics, et cetera. But eventually, the offline work, the analytics that you do, they need to be operationalized. That is the center point of a intelligence control platform or a system of intelligence of the future. So what does it take in terms of the technology and the workflows to put together something like this that will deliver that final output that you need of a system of intelligence, which also allows you to control at the enterprise level? So one is, obviously, I talked about multiple types of data in a broader context, and that requires you to do data ops functions. I can put that generally. The second part is that intelligence ops function, which includes machine learning, AutoML or OpenML, machine learning ops, rules, complex event processing. So it's not simply about offline analytics or online analytics or even ML. It is all of those. That's what makes an intelligence control system. So if you want to try to use the analogy, if you're familiar with process control systems, and we were to take it at an enterprise level rather than equipment and loops, that's the intelligence you need to build. And then that intelligence needs to be delivered through robust messaging, maybe publish, subscribe, maybe not, but then also not just messaging for consumption by humans, but also distribution of that intelligence, both at the edge and the cloud, for decision-making systems that run in an autonomous manner, including if it's on the shop floor, that intelligence delivery goes to a platform that can do closed loop control. So at the end of the day, what it means is what you need is that AIoT platform or platform as a service, but it should come with a set of integrated workflows that allow you to build and deploy those intelligent applications at scale. That means you should not have to worry about having to worry about the infrastructure or the underlying these three pillars that I've talked about, the data ops, intelligence delivery, should come in the form of a platform as a service. And unlike the systems of the past or the control systems of the past, what is clear here is that you need this technology to be continually evolving. That's what is different. Whether there are new algorithms, whether there are new compute methodologies, you should be able to ingest those into the platform. And that's why platform as a service with continuous integration and delivery, some of you might be familiar with CI/CD. That is what we have been building for the past 4.5 years. And through a series of iterations, customer feedbacks, to try to bring together that platform as a service so that you can focus on delivering applications. So we're going to start by covering that platform with a series of webinars starting today. So who are the people involved in building those applications and using the platform? No, it is not the data scientist alone. And no, it is not the subject matter expert alone. It is both of them. And no, it is not OT alone or IT alone. It is both. And no, we will not provide the best algorithms. We may not provide the best machine learning, which means it needs to be open to accept the best of breed machine learning or best of breed algorithms that are available to you. But at the end of the day, we give you those choices in a very tightly integrated, highly scalable platform where you don't have to worry about the workings of the platform, but you use it, you configure it rather than program it to build those applications that eventually deliver results. So a complete platform ensures lifecycle management, better security compliance, better compliance if you're into GXP applications, using the right location for the deployment of data and machine learning algorithms, and makes the distribution of that intelligence with a high performance publish subscribe communication from edge to cloud possible. Not all problems, as I said, can be solved with machine learning and data science. You need to use mechanistic models or first principle models, or in the process industry that we refer to simulation or dynamic simulation, which also needs to execute in the same environment. So what we've done is, in order to make that happen, we use the concept of nodes. So the top part that you're looking at is our node called the QPro node, which contains all those applications in highly integrated, tightly integrated workflows, and all the services that are required to make that happen. Whether it's the cloud compute services, whether it's the ML ops, whether it's the model training, inference deployment, and combining it with complex event processing happens in the QPro node. So when you're thinking of nodes here, these are software nodes that can be used to build an enterprise application, both at the edge and in the cloud. So essentially, you're able to now take these nodes and build an enterprise application through scaling both at the edge as well as in the cloud. With those nodes, you can connect with the platform with data from OT, MES, LIMS systems using the QLite node at the edge. You can also run machine learning models at the edge. And in the cloud, and we're cloud agnostic, in the cloud, you can scale horizontally by adding additional software nodes. So each node is a container using Dockers, both at the edge and at the cloud. And we use a microservices environment to ensure a high degree of distribution. And containerization, as I talked about earlier, containerization also removes the need for that DevOps, which makes you not focus on applications, but tends to take you to managing the platform, managing the infrastructure, et cetera. So containerization using Dockers, both in the cloud and at the edge nodes, allows us to do that. So we try to use the horizontal scaling technique here through these nodes. And part of that is, eventually you want that robust, scalable enterprise-grade platform, but you need to start small. So you need to scale, which means your infrastructure management, the compute infrastructure that you need, the software infrastructure, the services, the clusters, et cetera, you shouldn't have to worry about those through horizontal scaling as you use and get value from the platform, just like we have done with control systems, SCADA systems in our facilities. You're able to use that approach. So horizontal scaling gives you also that determinism of the compute infrastructure that you would need, and it doesn't slow down your return on investment. So with that, I'm going to turn it over to Vinod, who's going to walk us through the workflows needed and how all of this comes together. Go ahead, Vinod.
Thank you, Rajiv. So to really summarize and see in practicality what Rajiv has just spoken about in terms of architecture and infrastructure, we're going to walk through a journey in this next demonstration. On the screen here, we have different milestones of this journey. We're going to start at the bottom and look at connecting all those disparate data sources that we have. Once we connect those data sources, we're going to build layers of context. We're going to start at the physical layer of context, my equipment, my asset, my process unit. On top of that, we build operational layers of context. This allows us to be able to bring data from your MES, from your operational databases, and overlay this with your process and IoT data as well. Once we have these layers of context developed, we'll start to be able to build layers of intelligence. And this can range from something as small as a rule or an event frame, all the way up into machine learning models and digital twins. And once we have this entire journey of different layers of context and intelligence, we move into applications. And this is how the user consumes the actual intelligence and data. I want to be able to look at it from different perspectives, from a quality perspective, from an engineering perspective, from a business perspective, and all these are made possible with the same infrastructure in the Quartic platform. So with that being said, let's jump into the demonstration. Great. So this is the Quartic platform, and it's easily accessed through a web browser. So in my case, I'm simply using Google Chrome here. And in the platform, we have multiple different modules that services the different milestones as well as different user personas. We're going to start our journey at the very bottom, looking at the QNect module, which connects our data sources. So in this QNect module, I have multiple different sites set up. Let's look at the Pharmaco site to start off. In this Pharmaco site, I'm going to have different nodes. These are the software nodes as Rajiv had mentioned. So in this software node, I'll have my cloud instance, which runs the entire stack. And of course, the lower instances of the edge nodes that are connected to data sources. And it's very straightforward for us to be able to add a data source. The entire thing is done through a UI. And what this allows us to do basically is remotely manage and configure any edge devices from one central location. That way, the entire stack can be controlled by IT, but still managed and deployed on the OT level. So this is our first step. Deploy one of these types of connectors using a specific protocol to connect to an edge source. Once we have that connection, we essentially have data streaming in through whatever protocol being used. Our next step is to potentially scale. We could look at adding in multiple different edge nodes at different parts of my site, and even go as far as adding multiple different sites, with the idea that we want to be able to pull all these different data sources into one QPro head node. And that node allows us to be able to apply these different levels of intelligence. So once I've connected my data sources, I move into my second module, Asset Harbor. And this is where we start to build those layers of context. So if I jump back into my Pharmaco site now, you'll see that I have these different layers of physical context set up. For example, in my pharmaceutical site, I have a AMAP purification process unit, a clarification unit, a fermentation unit, which also has multiple different assets of different types. This is how we can arrange and categorize that data and use all this information coming in from those different data sources. And of course, if you have data historians that have specific types of data models, those can also be mapped to these internal data models. The intent here is to build in the S88 infrastructure and context as much as possible, while being able to expand that and allow that to be expanded to be used for intelligence. So we want to be able to leverage your historical efforts as much as possible. So in this 15,000 liter bioreactor, for example, I have a list of data sources that I can connect to based on those edge nodes that I've deployed. Each of these data sources come with specific parameters. For example, here I have process parameters. I can even connect to a specific PAT, an analytical piece of equipment, and pull in that information. And all of this is now shared under the context of a physical bioreactor named 15,000 liters bioreactor. That additional layer now moves into operational context. I can link in an MES system or other operational databases and pass in information like my batch phase, my batch ID, recipe. And now all this context can also be shared over that process information and IoT information coming in. Again, we can also link in your own data models so that if you've already made these efforts through pilot projects or through internal development, you can simply map your data models to these infrastructures so that it is simple to import that data and stream that data. We will also have future support for ontology and knowledge graphs so that should you have a larger goal of being able to map your entire site, we would be able to support that in the future. So now that I have my data connected and contextualized by my asset and potentially my operation, well, what do I do now? Well, this is where the different layers of consumption start. I can move into my self-service analytical portal and simply start consuming the data the way I have it. So any user can come into here and simply start streaming this data. So for example, here in my POX expansion site, I'm looking at the Sartorius reactor. I can pull in this information for my vessel temperature over the past week. regardless of where this data is coming from, I can overlay this with information coming in from a labware system, from an IoT system. I can even overlay this with specific information coming in from process data frames. For example, SIP. I can look at this information and say, well, when did my SIP start and stop, and have this all be contextualized in real time. I could also build custom event frames, for example, a period of high temperature that's identified by a machine learning model, and start to label my data in real time. This allows me to be able to prepare these data sets and prepare these operational frames for machine learning. And it's just one of the tools we have available that we'll do a deeper dive on. But of course, the next step, and people always want to move into, is intelligence, machine learning intelligence. How would I be able to consume this data from a machine learning perspective? Well, that's what we have our eXponence and intelligence engine for. That's Project Builder. When we jump into Project Builder, our entire intent here is to be able to consume that data from a multivariate perspective. But as Rajiv had mentioned, there are multiple different ways of doing so. I have my SMEs and I have my data scientists. So we allow both of them to be able to use that data and build machine learning models their own way. For example, the SME can come in to start a brand new project, choose one of the asset contexts we've created. So for example, that 15,000 liter bioreactor, see a list of all the targets and data sets we're streaming for that bioreactor. So let's start with, for example, the jacket temperature, and start to build machine learning models based on that. I'm going to select a quick range here. So let's say the past 10 days worth of data, and simply upload this data and start to create my data set. I can be as meticulous and clean this data set as much as I need. For now, I'm just going to move forward. And what we do is we allow to be able to build data analysis workflows. And these workflows are based on the nature of the problem being solved, not the actual machine learning model itself. So this AutoML suite allows us to quickly build a data set and take an SME or a user that does not have any deep data science background through this entire journey. So for example, here is my entire data set of 50 odd features for the past 10 to 12 days. And I can start to go down this workflow and build these specific models. And of course, these models allow us to be able to solve very specific problems. For example, baselining my asset to identify failures, or predicting what a soft sensor or my operation of my asset could be in the future, whether it's 5 minutes from now or 5 hours from now. Again, the intent is that this workflow is all containerized and contained within the same infrastructure that I connect, contextualize, and then build intelligence on. But of course, if I have much more complex intelligence, for example, a data science team building something, what I can do is also deploy an entire Jupyter Code notebook. So this lets me connect to the data set being pulled and simply write my own code using the Quartic API and SDK. I can build in that same infrastructure of data. I can extract the same features. I can extract the context, all available, and build in whatever code I need to deploy a model in real time. And this model is treated just as the AutoML model would be, which means that I could save in a specific model to be a soft sensor or a soft tag and have this model persisted throughout the process, which means in real time, if I go into my model library here, I would be able to see the inputs and the outputs of this model and compare them against the actual features, my previous historical data, or simply against other ML models as well. We can manage these models completely, whether through the Quartic AutoML flow or through the Jupyter Code flow. All of this is, again, intrinsically available as part of an internal solution. What this also lets me do is create soft tags, as well as transform my tags for filtering, for transformations, and write them back into the system. So I essentially have a way to be able to, in real time, amend these tags, transform these tags, and write them back into the system as just any other persisted tag. So once I have this intelligence, my next step is to, well, start consuming them. So there's multiple different ways we can consume them. We can simply build alarms and events. Alarms and notifications. We can have these alarm and notification trigger in real time and monitor my models in real time. But we can also look at the specific applications the way we want to consume this data. So for our demonstration today, I'm going to go through a few different applications. We're going to start with the reliability application, simply from a high level to understand what are the different concepts of the reliability application. So this application was built by conversing with industry specialists, as well as a lot of customer feedback, to implement the RCM process, which is the reliability-centered maintenance process. And this process focuses on identifying and capturing the functional failure modes of my different assets and monitoring those failure modes in real time. So for example, if I was to look at this asset, this autoclave here, and jump into a deeper dive of what this autoclave does, I can deploy machine learning models to capture specific failure modes of this autoclave. And these failure modes can be something as simple as a pump motor failure or even a mechanical failure. And of course, the interaction and development of these failure modes and the models to capture these failure modes can be done through the AutoML suite, or can be done through the Jupyter suite, where you can write your own specific code. The intent is, once we deploy these models, and I'll just navigate here to a different timeline. Once we deploy these models in real time, we can capture not only whether these failure modes become active, but also how often they're becoming active and how they contribute to the overall risk of the asset. And the way we do that is by following the FMEA process. We understand what the risk is of that specific failure mode, and we can identify and attribute a risk index to that failure mode. So in real time, Quartic will manage the entire risk of that asset by compiling all the different failure modes and notify you as each asset goes through its abnormal period operation, how that risk starts to increase, and whether or not it reaches a level where it needs to be addressed. So for example, the last overhaul date for us is a key indicator of that. We can see since when the last time this asset has been maintained, or a life-changing repair has been performed on this asset, and we can compare that and see, well, how the risk has been increasing since that time. This is just a high-level overview of this application. We can get a little bit more detail in our subsequent webinars. But the intent here is to be able to monitor this process or any assets under this process in real time without having to do the manual work of evaluating this process every day or every week. So what I'm going to do now is jump into another application that showcases more of a manual investigative workflow. So I'm quickly just going to navigate to my second screen. So what we've done in this specific workflow is we've started to pull in the context that we've created in our previous steps. So we started to create context of assets, operations, and product. What I want to do now is focus on this process unit. I can pull in one of the specific process units that I created, and I can see all the different batches that are available in the timeline that I've chosen. So in this case, about a month in December to January. I can also start to be able to analyze this data from a multivariate perspective, follow a simple batch analytics process to be able to set up, to be able to analyze my data from not only one asset, but every asset under my process unit. So for example, let me select all my different features, and let me look at something like my yield of this process in this fermentation process unit, and see the different setups, see how my different features are essentially captured within this 2D plot. So this is performing a simple PCA reduction, dimension reduction here, to capture the variation of all these different parameters together. I'm further sizing this parameter by my yield to understand basically, well, what are the different yields of these batches and how they affect each other. So I can ask a very simple question here. Why do I have some batches that are large and some batches that are maybe not so large in yield? So by simply selecting these batches and then comparing them against my smaller batches, I can do a very rudimentary analysis to understand what are the key factors that differentiate these two groups of batches. So for example, it's highlighting my inlet pressure as a potential difference, and I can see the difference between these two groups of batches. As I start to go into the different features here, I'll start to see information that potentially could lead to the next step, which is, now that I have a feature that might be different, could I deploy machine learning models to be able to capture this a lot more holistically? And that's our next step. We can look at deploying a machine learning model or this specific model in real time, so that as my features come in, I can select a high yield model, and I can select my new batches as they come in real time and compare them against these models. So this is an example application that's using the entire infrastructure that we have set forward. What we've done is connected our data sets. we've contextualized this data. We've contextualized it in terms of asset and gone a step further in terms of product. We've brought in this information into our analytical application, created a group or a series of batches that we may consider a high yield or a golden set of batches, and then compare the real-time set against these as the batches are happening. We can even send this information now back to our alarms and notification screen so that should I receive some sort of information that deviates or warns my batches, I can create an alarm, a notification, or even a write back to a CMMS system or a work order to be able to alert my users of what's happening in real time. I can take it a step further and say, well, I also want to manage this process in real time. What can I do to be able to look at the actual batch trajectory? So I can jump into my trajectory screen here and see as my batch is occurring, what the expected rate or what the expected direction of my batch is. And should my process be able to follow that? Or if not, how is it going to deviate from that process? So this troubleshooting method and this investigative method is an example application that we had built to be able to follow through an entire investigative workflow of the user itself. And the idea of this is, well, once I start to be able to get control of my process and understand all the features that deviate or influence my process, I can build specific machine learning models to monitor them. This gives you a much better way to be able to build machine learning models of value instead of trying to summarize the entire process or predict the entire process. Again, just another example application of what can be built on top of the Quartic platform. The third application that I'm going to go into is an optimization application. So let me just quickly navigate to that. So in this application, what we're going to do is essentially connect to a process and see how we can monitor and control this process in real time. So what I've got is a digital twin of a penicillin process in my backend. I'm going to connect to this process as if it was a real process. And I can see the breakdown of my recipe for this penicillin fermentation process. So I have a few different things here. I'm going to start at the very top with this objective. Let's say my objective for this penicillin fermentation process is to maximize my yield. I can build in as many constraints if needed, if I want to be able to keep specific features or specific parameters or measurements under or above certain limits. And here are my control parameters. I have different control parameters that come in, and each of them have its own recipe that it's going to follow. And that's displayed in this chart here. So for example, my sugar feed rate looks like it's going to increase, drop back down, and then over the 200-hour process, slowly increase itself. And I can see all those set points here. Now, what this tool lets us do is have Quartic and its intelligence suite monitor this process and optimize this process based on the objective, which is to maximize my yield. So in today's case, because I'm not able to change my process profile, I'm just going to suggest 15 runs for Quartic to navigate within these expected runs, within these expected deadlines, and see how well it can optimize its process. So here is my setup for my first run. Because I'm running in a simulation environment, Quartic can run these 200-hour processes very quickly. And in this case, it's going to change these set points at these different set marks and see how well that affects my actual yield of the process. So what this lets me do is build in a very strict optimization workflow that can be connected to your control systems if needed as well. The idea here is I can monitor these individual parameters. I can go through these different runs and see how these individual influences affect my actual output here. So this is going to run in the backend. It's going to take some time to essentially go through its workflow. But this output can also be sent back again to a controller, can be sent back to a database, or any other thing, any other alarm and notification can be built on top of this as well. Our intent with this is that it allows us a non-invasive way to be able to monitor the process. And should I have any legacy data or legacy batch information ready, I could even pass that information into Quartic to allow that information to be used to optimize and accelerate my process. The intent here, again, is to show a workflow and an application that has been built on top of that infrastructure. In our subsequent webinars, what we're going to be doing is taking deeper dives into this specific workflows. We'll go through the different applications, for example, the reliability application, the MVDA multivariate application, and a deeper dive into the project optimizer to be able to see what the mathematics are behind them, the usefulness of them, and how they can best be applied to your specific processes. Today's overview is just a high-level overview of that. So with that being said, we're going to navigate back to our deck. And I'll stop sharing my screen.
Thank you, Vinod. And I think we'll transition to the Q&A session now for everyone. So I'm going to open up the first question that we have, and this one may be for you, Vinod. It says, in the enterprise schematic that you presented, where do you see master data management applied, at the source data level or at the aggregation layer?
It is absolutely going to be applied at the aggregation layer. So one of the things that I did not go into detail today was showing our ETL process that happens at the edge layer. And that ETL process allows us to be able to apply some sort of data management techniques, which means I can look at information like my tag units, the frequency of my tag, the granularity of my tag. All that information can come in and be applied at the edge layer. But as it gets pooled up and the context gets built in the cloud, that's where my master data management really kicks in. So this is where I start to apply information with my context. I can start to relate the context, not only in terms of, again, a product, asset, and operation, but also in terms of different campaigns, different lot IDs. And this can be used in a larger scale to be able to share and compare the batches over a campaign as well.
Great, thank you, Vinod. We have another question. The question is, there are many different applications already available for advanced analytics. Why is an Industry 4.0 platform more advantageous than using these individual applications or building one in-house? And I'll go ahead and take a shot at that one, and then maybe I'll look for Rajiv if he has any input there as well. So from my perspective and what I've seen across industry is you sort of look at operations sort of like the evolution of ERP, and what it comes down to ultimately is supportability, sustainability, and most importantly, scalability. So when you look at that of, say, building something in-house, a lot of companies are looking to say, we don't want to spend our efforts on supporting and maintaining systems. We want our efforts to be on delivering value to the user base, which ties into the second piece that I'd say is important. And that is really driving collaboration. When you look now, sharing data using multiple personas in different roles, be it engineering and operations and reliability teams in collaboration with the subject matter experts and data science, it needs to become easy. It needs to become easy to make that self-serving, to empower everybody to quickly and efficiently use the same tools and applications to support those different roles and to easily collaborate with people. So I see it, there's two pieces of that. There's that end goal, sort of like our ERP software journey is we need to put things in place that we can easily support and sustain and can scale with us. And then we need to really listen to our end users and deliver something for them. And I'll turn it over to you, Rajiv, if you have any other input there.
No, the key there is operationalization, right? So yes, there are a lot of analytics applications, workbenches, etc. But as I said in the beginning, at the end of the day, if you're building a platform, you're building a platform of intelligence. Any analytics that you do take up a lot of time. Once you've done a good analysis, can you turn that into a model, which is doing that analysis real time and giving you the intelligence? That is the key. That's what an Industry 4.0 platform will do, different from analytics as they've existed in the past.
Thank you, Rajiv. I'm just looking at. I've got one more question. Is it possible to implement these ML models at the edge? So I'm happy to
You
answer
can
that,
take
but
that one.
yep, I was going to turn it over to you, Vinod. Go ahead.
So absolutely. The way we deploy our edge node is essentially a proxy node that is able to connect to the edge data sources, stream that information into Quartic. But the way we deploy our MLs is a completely containerized environment that can run in a cloud, on a VM, or a lightweight machine at the edge as well. Thank you for bringing that up. So as shown on the right here, we have the edge node, which is the ML square in black, lying at the exact same place as our QLite nodes, which is the data streaming nodes that connect to data sources, whether they're MQTT, IoT data sources, or data historians as well. That ML node is a completely containerized node that has the capability to run your entire model, as well as, if needed, right back to a data source or right back to the edge if required to.
Okay. At this point, I do not see any other questions. So with that being said, we can probably look at closing out, moving to our final slide. And I'll just add a few closing comments for the audience. First, up here, you should see the schedule now. As noted at the beginning of the webinar and throughout, this is just the start of our series. So the next two webinars will focus on Q data and Q intelligence, and we'll look for nailing down specific dates for applications as well. So keep an eye out for those, and please mark your calendars for that. Additionally, we'll be sending out a survey just to solicit your feedback and thoughts and how this webinar series, and this one specifically, was it beneficial, and how we can help you moving forward with all of your digital initiatives. So with that, please enjoy the remainder of your day. And if you have any other additional questions, feel free to reach out to us. Thank you for your time.